Good morning, everyone. My name is Harrison Lee, and I'll be your tour guide for the Green Army Project. We'll be examining how the U.S. military plans to transition to alternative energy practices and how much it costs, as well as the upsides and downsides of the projects. We'll be examining everything from systems analysis to retrofits of current buildings to even the use of special microgrids, which are a brand new thought process and run parallel to standard electrical grids. We'll take a look at how Congress has reacted, how the military plans to implement everything, and what the final decision will end up being. So, why would the military want to go green? And the simple answer is that the U.S. military wants to cut down on costs and make itself more self-sufficient. That means reducing the load on current existing power networks and making soldiers self-sufficient out in the field. How do you do that? Well, the military is experimenting with different things like, as previously stated, the microgrid, thermoelectric recovery systems that convert waste heat to new energy for equipment, and various other methods of retrofitting old buildings to make them more efficient. It aims to cut down on costs and make everything a smoother experience for the military. The military is already investigating the use of several different technologies, including the aforementioned heat recovery systems. They're currently being investigated as a way to cut down on costs and make sure that nothing is being wasted when resources are tight. The most interesting use, perhaps, is the life cost analysis, which aims to analyze which systems in a military base are extraneous, cut back on them, and retrofit current buildings to be more energy efficient. We also have solar-powered electronic devices that are being used on equipment and vehicles to save energy and reduce the use of batteries. Thermoelectric recovery is one of the more recent technologies that's been tested on the new Shadow unmanned aerial surveillance drone. The thermoelectric energy recovery is designed to utilize waste heat that's given off by humans and vehicles and convert it to usable energy. It's sort of like what cars use in hybrids when they use kinetic energy recovery system. It's used to use excess energy and convert it into a useful form rather than just wasting it and relying on aging battery technology to carry you through. The life cost analysis model takes a different approach. Rather than create new technology to fix old problems, the life cost analysis model takes a look at what existing problems there are and how they can be solved with current technology rather than looking forward to the future. It's designed to retrofit old systems that are wasting energy and excess systems that add unnecessary cost and trim them down. It can be completed over several years or less depending on where the site or analysis is conducted. It cannot be used to create new facilities and is only designed to trim down the fat of old facilities and optimize their usage. The microgrid system, currently being investigated by the Navy, is a new idea that basically creates a small electric grid that runs in parallel or completely separate from regular electric grids. It improves electric systems reliability and stability for customers within the microgrid as it does not rely on the generators from outside and has a much smaller power draw. It allows for more implementation of renewable and alternative energy sources like solar energy due to the smaller grid scale and the ability to be self-sufficient. It might reduce operating costs as it cuts out the middleman in energy distribution, but getting to that point will cost a lot of money and resources that the government may not be willing to allocate. The military is also attempting to look into alternative energy options, whether it's electric engines that are quieter, lighter, and better, or using less oil and more alternative and local fuels like biofuels. While green fuels and electric engines are great, the problem is that there simply aren't enough of them to meet the military's demand. The amount of oil the Air Force alone uses in its operations is more than all of Denmark combined, despite the fact that they're looking into alternative fuel usage. The problem isn't the fact that it can't be done, it's just that the scale is far too large for biofuels and alternative energies options to be a viable method. The reality of going green is that it's going to cost a lot of money. It requires a lot of research, a lot of manufacturing, and there's a lot of speculation as to how much is actually saved in operating costs. This is part of the reason why Congress is often reluctant to fund new research projects without some sort of proof or evidence that these technologies do actually have a positive impact. Everything requires budgets for efficiency on a microscale, but getting that funding is the challenge. While some of these technologies are great in theory, the reality is that when they're implemented in practice, it's just never smooth enough for the government and the military to okay their usage. And at the end of the day, everything relies on the uncertainty. Can the military go green? The answer is a bit twofold. The military could go green if it wants to save on operating costs and make itself more self-sufficient, but it might not want to do that since the price tag is pretty high and there's no guarantee as to what the actual savings will be. It also takes time, commitment, and diversion of resources and assets in order to evaluate whether or not these systems actually work. They also have to have enough of the alternative energy sources to make the military sustainable. At this current time, the military probably couldn't go green, but in the next 20 to 30 years, for sure.